Today we're going to talk about tangent. We didn't spend too much time until now talking about it. We normally concentrate just on sine and cosine, but in fact tangent is also an important function. Yes, it could be produced using knowing sine and cosine, but by itself it's a cool function, and actually in real life we often see probably more tangent than sine and cosine. For example, when you drive on the road in the mountains, you may have a sign saying steep slope, and it may say, put a number there, say 10%. And the question is, what is that 10%? And that 10% is nothing more but tangent. So today we're going to rectify some of the misdeeds we did before by solely concentrating on sines and cosines. And today we're going to say, well, sorry tangent, we're going to pay more attention to you in future. Okay? So today is the start. So now I have this unit circle. You've seen it a million times. So now the question is, this circle tells us about sines and cosines, and that's what we used it for before. But does it tell us anything about tangent and maybe cotangent? And the answer is yes. The only thing you need to look in the right spot. And the right spot is here. So whatever you see, there's a vertical line here, that is a tangent line. It goes through the point A, point 1, 0. Okay? And what we need to do when we want to find the tangent of some angle x is to find where this angle intersects this tangent line. The coordinate of this point B on tangent line will be our tangent. Now, A corresponds to 0, tangent equals to 0. Now, everything above is positive, everything below is negative. So point B got on the positive side of my tangent line. So now, why is this point, why is coordinate of B will be our tangent? So if you look at this triangle, OBA, it's a right triangle, and we know definition of tangent through the right triangle. It's the ratio of opposite leg to adjacent leg. Opposite leg is AB, adjacent leg is OA, okay? But OA itself is 1 in this case. It's chosen to be 1. So it means that tangent is just this length AB, okay? What about the angle like y, right? Angle y is a negative angle. In fact, this angle is between minus pi over 2 and 0. So what's happening here? Well, we draw this angle and find where this angle or line, orange line, intersect the tangent line. That's going to be point C. And point C is below point A, below 0. So in this case, C is in the negative domain, in the negative half of the tangent line. So coordinate of point C is negative, tangent of angle Y is negative. Okay? Now, okay, we dealt with the first and the fourth quadrant. What about quadrant number 3? I have this angle X. If I get this angle, get this orange line, which really not really the line, it's a ray that starts at point O and goes away. That ray does not intersect my tangent line. What should we do in this case? The truth is, we just need to extend this ray to the full line and see where this line intersects the tangent line, okay? Tangent axis. It intersects at point B, and coordinate of point B will be the tangent of this angle X. Well, in this case, B is positive, coordinate of B is positive, so really tangent X is the length of segment AB. Okay? Now, also from what we see here, we probably now get that really any angle that lands us on this orange line will have the same tangent. So for example, this angle x minus pi is also going to have the same tangent, right? And it will, yeah. The line that give us both of those angles intersect at point B, intersect the tangent vertical line at point B. So both of these angles give me the same tangent. What about if my angle is in the second quadrant? Same story. Extend it, the full line. Find the intersection with the tangent line, point B, and coordinate of this point, which in this case is going to be negative, is tangent of this angle x. All right. So far we talk about tangent. Let's just say a few words about cotangent. Cotangent is not as common function as tangent. Nevertheless, we see it once in a while. Tangent, remember, is sine divided by cosine. Cotangent is the opposite. It's cosine divided by sine. It turned out that cotangent also could be seen on this plot. And that's going to be this horizontal line going through the point 0, 1. And now again, I get my angle. I find that where the line for this angle intersects the cotangent line, the horizontal red line, and coordinate of this point B will be my cotangent. Now, whatever's on the right of point A is positive values, whatever's on the left, negative values. Okay? And the story is the same also with an extension of the ray. So if my angle doesn't intersect with cotangent line, I just need to extend my angle line to the full line and find where that line intersects with cotangent line. Same story as with tangent. So in reality, we see that this unit circle actually could be used to look at not two functions, not just sine and cosine, but also at tangent and cotangent in a nice way. All right. This is the simplest problem, tangent x equal to 1. So how do we solve it? Again, we get our unit circle, we get our vertical tangent coordinate, tangent axis, and we find a point on this axis where coordinate equals to 1. It's going to be somewhere here. It's really going to be the same height as this one, okay? It's going to be here, okay? That's point B. Now draw a straight line through B and through the origin of sine and cosine's coordinate system, point O. And now all angles that get you this line going to have tangent equals to 1. Let's start with this angle. We can get this angle very easily from the right triangle. What right triangle, what angle would be here, okay? And we actually studied this. If you remember, if tangent equals to 1, it means the opposite leg and adjacent leg should be the same length, right? And we know this is 1 and this is 1. In this case, I have isosceles triangle that has two congruent angles. This angle we are interested in and the other one, angle B. And those angles have to be 45 degrees, or in radians, it's pi over 4. Okay? So pi over 4 is one of those angles. Now, we see that if we take this pi over 4 and add half a circle, okay, we're going to get to the same line. And that angle should have the same tangent, right? This angle is pi over 4 plus pi, okay? So that's another one. Now, obviously, if I add another pi, I'm going to land on the same line again, okay? The other thing we can do, and we can actually continue going, adding pi as many times as we want, and we will always land on this line. And all this angle is going to have the same tangent, equals to 1. Now, obviously, we don't have to go counterclockwise. We can go clockwise. We can go to negative directions, so we get pi over 4, and then minus pi. Again, we'll land on the same line. Tangent equals to 1. What if you do another half circle? Pi over 4 minus 2 pi. And again, we're there, right? So I guess you probably get the point. The point is the correct answer if you want to count all possible value of x, it's pi over 4 plus pi n, where n is any integer. All right, let's move on. A little bit more complicated, but not terrible. Tangent x equals to minus square root of 3. Okay, our circle, our tangent line. And now we're going to put this point B correspond to coordinate of minus square root of 3. Now, what angles correspond to this point? All the angles that takes you to the orange line. Okay, the first one to think is this angle. Okay, what is this angle? We know the tangent of 60 degrees, so pi over 3 gives us square root of 3. Okay. Now, also we should remember that tangent is an odd function like sine. It means the tangent of minus pi over 3 will be minus square root of 3. That minus just pulls out in front of tangent. And that's exactly this angle. Okay? And now the full solution is what? This angle minus pi over 3 plus or minus any number of half circles we can add or subtract to this angle, right? That's our answer, is minus pi over 3 plus pi n, where n is any integer.